Welcome to Sri Nebula Tune Brahmacharya from SNJP, KKJ Arts, SNGR, SN, SMGR Commerce and SPHG Science College, Chandpur, Nasik. I am Professor Anil Gite from Department of Physics, and let us today discuss two concepts on the lasers. What is the laser? Two basic concepts or processes involved in the laser action. First of all, what is laser? In laser, the word L stands for light, A stands for application, S stands for stimulated, E stands for emission, and R stands for radiation. So light amplification by stimulated emission of radiation. So there is amplification of light by the process. The process is stimulated emission of radiation. Means we have to see the meaning of each word. So first of all, what is light? Light. Then what is amplification? What is the stimulated emission? And what is radiation? Okay. So when we see light is a form of electromagnetic radiation. It is a form of electromagnetic radiation. The second, amplification. Amplification is for the increase in the strength of that radiation. How to increase the strength or how to amplify the strength of light. That is the process, that is amplification. Means we have to amplify or we have to increase the strength of electromagnetic radiation by the process, and the process is stimulated emission of radiation. So later on we will see is the stimulated emission and what is the radiation. So first of all, what are the properties of this laser light? It is a light. So what is the property of this laser light? So first of all, the laser light is monochromatic in nature. Monochromatic in nature means this laser light has a single wavelength, unique wavelength. So unique wavelength means it has a specific color only. Then the laser light is coherent in nature. That is, all the waves which are emitted by the laser light, they are in phase or they are same phase. Every wave moves in a single state or in a same state. These laser lights are directional in nature. It is beam which is coming from the laser. This is very tight. So it moves in a single way, single direction. So it is a very strong and concentrated beam of light. So if you study the difference between the laser light and ordinary light, this is ordinary bulb light. Bulb light photons or light rays, it moves or light waves moves in every direction, any direction. That is normal light. So these wavelengths are not monochromatic, these are not coherent, these are non-directional in nature. So but if you take a laser light is coming like this red light. So what will happen? The waves which are coming from the laser light, they possess the monochromaticity and the same color. They possess the coherent, that is, they are having moving with in same step or in phase, and they are highly directional in nature. So these are basic properties of laser. They are monochromatic, coherent and directional in nature. So in laser, what happens that we are getting these properties as compared to the ordinary light. To study the laser, we have to study certain concepts. One is absorption and another is emission. So what absorption generally takes place? When we say absorption, in case of an absorption, if we consider any matter having energy states. Suppose this is the matter, it has two energy states. First of all, I will say this is zero is represented as a ground state or lower energy state, and the one represents the higher energy state. Generally what happens, the number of atoms, they reside at the lower energy state and the higher energy states are empty. So when light is incident right, sufficient energy is incident on the lower energy state or ground state, what happens? The electrons in the ground state will get that energy or absorb that energy and move to the excited state, to the higher energy state. Remember that for absorption to be takes place, the incident photon which is incident on the lower energy state or ground state should have sufficient energy so that electron will move from ground state to the higher energy state. So this motion of electron from ground state to higher energy state is absorption process. Remember that if the incident photon does not have sufficient energy, then absorption will not take place. If it has a higher energy, then also the electron will not move to the higher energy state, since it has very large amount of energy. It will go to the above states, not the excited state. But depending on the number of states present to the electron, where it will go, that will decide the higher energy of instant photon. So this is the process of absorption, that is in the process of absorption, atoms or electrons in the lower energy state absorbs or take energy from the incident photon goes to the higher energy states. This process is within the process of absorption. So this atom which goes in the higher energy state, atom which goes into the higher energy state, in the higher energy state that atom is unstable because it is in higher energy state, so it does not feel to be stable. So what will happen? It suddenly tries to come to the downward or in the ground state. This process in which the atom from excited state comes to the ground state, but while coming to the ground state, it will emit the extra amount of energy in terms of photon. So this emission is called as spontaneous emission. So in spontaneous emission, what will happen? The electron comes from higher energy state to lower energy state and emits photon in any direction spontaneously. This process is called as a spontaneous emission. But what will happen? We will try to incident another photon on the higher energy state itself. Higher energy state itself, that is, we will force the electron to come to the ground state from higher energy state to lower energy state. You may have doubt that it is already tried to come from higher energy state to lower energy state automatically, then why we have to force it, or why we have to stimulate it with the help of extra photon. Since when the electron is in higher energy state, its lifetime is very small. When lifetime is very small, what will happen? It will directly come to the lower energy in process of the spontaneous emission. So when we are taking the stimulated emission, we will incident another photon on the electron in higher energy state, and we will try to stimulate it, or try to stimulate it, try to force it to come to the ground state. So when we as one photon as a stimulus and another photon emitted by the electron coming from higher energy state to lower energy state, use two photons. So these two photons go in single direction. This process is called as a process of stimulated emission. So in spontaneous emission, atoms comes from higher energy state to lower energy state spontaneously and emitting energy in any direction for the spontaneous emission. But in stimulated emission, atom which is present in the higher energy state, we will incident extra photon on the higher energy state and try to stimulate it to the lower energy state or ground energy state. So incident photon and photon emitted by the electron coming from higher energy state to lower energy state. So the two photons are emitted from the atom. So these two photons are highly coherent, monochromatic and directional in nature. So the process of stimulated emission gives the laser. So these are three processes: absorption, spontaneous emission and stimulated emission involved in the laser action. So basic operation of a laser. What laser actually consists of? Lasing medium is found to get the electrons to an excited state using the intensity of light. If you consider there is ground state, there is excited state. When you give the energy to the electrons in the ground state, the electron will directly move to the excited state, that is higher energy state, where the lifetime is very small, about 10 raised to minus 7 seconds. So what will happen? The electron in the excited state spontaneously start to stabilize it, start to become stable. So it will come to the its lower energy directly. It does not come to the ground state. It will try to come to the lower energy state where it possesses more lifetime, about 10 raised to minus 3 seconds. So you can say that one lifetime is more than the lifetime in the excited state or higher energy state. So when electron absorbs energy, goes to the higher energy state having very small lifetime, 10 raised to minus 7 seconds, and from higher energy state it will come to the another state where lifetime is more, 10 raised to minus 3 seconds. That state is called as metastable state. The state in which the lifetime of electron is large as compared to the excited state. Such a state is called as a metastable state. So in metastable state, here we can offer the electron an excited stimulus. Why excited stimulus? Because they stay in the metastable state for a longer time. That's why we can able to incident a external photon on the metastable state, and this process of stimulated emission will occur here in the metastable state where lifetime is large, about 10 raised to minus 3 seconds. But if electron does not, or if that material doesn't exist in metastable state, what will happen? This excitation, after excitation, the atom directly comes to the ground state, emitting the photon in any direction. So that is the spontaneous emission. So first absorption, then spontaneous emission is from higher energy state to lower energy state, but the electron or atom moves to the metastable state, and in metastable state the process of stimulated emission occurs where the lifetime of atom is more, and we can able to give the stimulus to the atom in the metastable state. So the electrons rapidly fall to the metastable state. Why? From higher energy state, lifetime is very small. Lifetime is a time for which the atom or electron remains in that particular energy state. That is called as its lifetime. And lifetime of atom in the metastable state is higher as compared to the lifetime of atom in higher energy state or excited state. So in excited state, lifetime is 10 raised to minus 7 seconds, and in metastable state, lifetime is about 10 raised to minus 3 seconds. So atom directly comes from excited state to the metastable state where atom possesses higher lifetime about 10 raised to minus 3 seconds. So what will happen? The stimulated emission occurs in a cascade effect in the metastable state. That is, incident photon is stimulated on the atoms present in the metastable state. The stimulus will force the atoms to come to the ground state, giving out the process of stimulated emission, and the process of stimulated emission gives the laser action. This is only I have shown the material or what actually laser consists of. For example, there are different types of laser. We have taken just an example of a ruby laser. In ruby laser, these are the two mirrors. And this is the lasing medium, or you can say that ruby material or ruby flash rod is there that is placed. And what will happen if you want to make the laser transition? First you have to make the absorption. To make the absorption, you have to use the external source so that atom will move from the ground state to the excited state. So what will happen? You have to incident a flash of light, and that flash of light will act where the flash of light will absorb ruby medium or ruby atoms will absorb. Okay, so they will exert, which is excited atoms, then the emission will take place, and then there is laser action. This is one example how the laser is there. Okay, so laser media, so there are two mirrors. Mirror is the one is 100%. So this is what will happen. When light is incident within the cavity, there is stimulated emission will occur, or they have to move in any direction. So what will happen when flash of light is incident? Flash is incident, so they will absorb the energy. What will happen? The photons will move within the cavity, within the rod, in forward and backward direction, and from semi-transparent mirror we are getting the laser light. Right? Laser light we are getting. This is flash of light. Okay, flash of light is incident. So this is the process shown over here. There is resonance of the photons within the cavity, and from one side mirror, which is 100% reflecting, there is no emission because all the photons will reflected back. Here it is semi-transparent. Within semi-transparent, those photons which are closed directional monochromatic, they are emitted and they give the laser light. So this is the basic concept. So this is the ruby rod. Flash lamp is used. Then mirror 1, mirror 2. One is 100% another, and semi-transparent mirror is the laser effect. So other types of laser, there are basically 3 types of laser, depending 4 types of laser depending on the lasing medium used. So one is solid state laser, another is liquid laser, third one is gas laser, and another is semiconductor laser. In solid state laser, solid rods or solid metals are used for the lasing action. So ruby laser or ruby metal is a solid, that's why ruby comes in the solid state laser. In liquid laser, liquids are used. Various chemical dyes are used for the laser transition, so they are called as the liquid laser. Gas laser, argon laser, or gas is used as the lasing medium. So argon laser, used in eye surgery. Laser light shows blue, green light, carbon dioxide. Semiconductor laser, then diodes are come in the semiconducting materials. That is laser pointers, CD. These are the barcode readers, also the types. So 4 types: solid, liquid, gas, and semiconductor. These types depending on which kind of lasing medium is used. If your lasing medium is ruby or solid, that is solid state. If your laser medium is liquid, if lasing medium is gas, gaseous. If laser medium is semiconductor, is semiconductor. Okay, thank you.